Hi, I'm Kevin Hans Anaklang from PKE1. Today I'm going to demonstrate the simple circuit that consists of parallel and series combination. So this is the schematic diagram of a simple circuit. So to calculate the partial current, we need to apply KVL both loop. So minus 3 plus V1 plus V2 equals to 0. So we have this equation. And then also loop 2 is V2 plus this one. Okay? And then we have the second equation. So we do the math. So as for IA is I1, IB is I2. So we do the simultaneous equation. IB is equal to, or I2 is equal to 1 milliamps, and then I1 is equal to 2 milliamps. As for the Kirchhoff current law, we need to find the I3. We need to subtract both the current previously, so we get 1 milliamps. So the total current when we add up for the CL in this junction is equal to entering equals to leaving, which is 2 milliamps. Okay? So I2 is added with I3. So as for the partial voltages, we need to find V1, V2, and V3. We need to apply the Ohm's law. So V1 is 2 volt, V2 is 1 volt, V3 is equal to V2 because it's parallel equal to 1 volt. So as for the total voltage from here to here, so in this loop, so in the closed loop, when we add up all of the voltages equal to 0 volt. Same goes with loop 2. So alternatively, this plus this is 3 is equal to this. So next I'm going to demonstrate the construction of the circuit. This is the construction of the battery. So it's what we can see here. For the breadboard, the horizontal hole between the horizontal hole is not connected, while the vertical one is connected, except between this gap. So we need to also connect it. So the first one, we connect this one to this one, which is horizontal. The second one is connect this one and this one. Notice that two parallels are actually, two resistors are actually in parallel because they share the same node, and this one is series. So as for the battery connection, remember red is always positive, black is always negative. So the first one is measuring R1, which is actually this one from the schematic diagram, which is series. So note that this one is positive and this one is negative. So the measurement is taken as 2.099. So this one is the V2. So positive, the upper one, the lower one is negative. So the measurement is recorded as 1.039. This is V3. So fortunately the measurement is the same as V2, which is 1.039. As for the current I1, we need to break the connection. Notice that I break the R1 from R2. They are actually not connected. So we need to probe using the multimeter so that we can measure the current. It is noted that from the measurement it is approximately 2.12 milliamps. For the current I2, we also need to break the connection, this R3, so that we can measure the I2. So it is noted that the value is 1.05 milliamps. For I3, we need to break the connection of R2, and then we measure it between R2 and R1 like this. Okay, so noted that the connection is already break. So according to the multimeter, the value is 1.06. For the total voltage for loop 1, we need to probe from R1 to R2. Note that the value of the multimeter is recorded as 3.137. For the total current, I1 is also the total current, but we need to also measure from the other side. So the value from the multimeter is equal to 2.12. This is the comparison between the measured value and the theoretical value. So as for the measured value, we also, of course, expect some slight deviation due to the measurement of battery is 3.15, which is 0.15 deviates from the theoretical value, which is 3 volt. So in theory, the total voltage is 3 volt, and for V1 is 2 volt, V2 and V3 is 1 volt, and then for the measured value, it deviates slightly from a second decimal point. It starts to deviate, but it's fine because in practice we need to consider error in the measurement. So as for the partial current, it also have some deviation also. Okay, for I1 we have 0.12 error here, this one, and then we have I2 and I3, which is slightly less deviation. Okay, because in measurement we need to consider the error or the deviation between the during the probing, okay, because it's totally a normal case in engineering. So as for the total current, it's actually equals to I1 2.12. Here is 2 milliamps. So in engineering we need to consider sometimes approximation for this measurement, because this is some slight like redundant value that we can ignore, and it still worked. It's still fine. And then the reason for this measurement is because the manufacturing sometimes it accounts for the uncertainty value. For example, the battery is 3.15. So in the product, maybe it indicates 3 volt and then plus or minus something, maybe 0.15. So that's the reason for the uncertainty value, because in real life we cannot manufacture something that is precisely the value that we need. So that's all for my video. Thanks for watching.